Hey guys, welcome back to my playlist, which focuses on the IGCSE Edexcel Maths 8 questions. In this playlist, we're discussing all of the topics that come in IGCSE Edexcel Maths 8, higher, both H and HR. You can also use this playlist if we're doing GCSE Edexcel Maths, Cambridge Maths, or O-Level Maths. In this video, we're focusing on trigonometry, and the sub-branch is going to be Pythagoras. We'll be discussing all of the different types of questions that come for Pythagoras in the higher exam. You can also use this video to study if you're doing foundation. So without further delay, let's start with the questions. From point A, Stanley walks 200 meters due east to point B. Then from point B, he then walks 160 meters due south to point C. We have to work out the length of AC. So for this, we will make a diagram using the directions given in the question. So as you know, it's saying that from point A, Stanley is walking towards point B. As you can see, the question says from point A, Stanley is walking to point B, and that's towards the east side. So this is from A to B, and this is 200 meters. Then from B, then walks 160 meters due south to point C. That's over here. This is C. We have to find the length of AC. So if you're familiar with Pythagoras, you know that the formula for Pythagoras is a square equals to b square plus c square, where a is your hypotenuse. That's like a fixed case. It will always be the hypotenuse for a. And the other two are going to be opposite and adjacent. Hypotenuse is always your diagonal length. So this is your hypotenuse. And opposite adjacent can vary depending on what your reference angle is. So right now we're not focusing on the angle, so you can make either of the lengths opposite or adjacent, but the hypotenuse will be the diagonal length. Now, as you can see, we have to find the hypotenuse, which is AC. So it's going to be AC squared equals to 200 squared plus 160 squared. A lot of kids make this mistake that they confuse like what's going to be A, what's going to be B or C. Just remember the hypotenuse is alone on one side and the other two are being added on the other side. So hypotenuse square equals to opposite square plus adjacent square. A square equals to B square plus C square. Also, you can remember it as ABC. A comes first, then B, then C. So A is this, B is this, C is this. So going back to the breaking, AC squared equals to, now you find the value of 200 squared. So 200 squared plus 160 squared, that's going to give us 65,600. To find AC, we will square root 65,600, which is equal to 256.12 meters. We want the answer correct to three significant figures. So three significant figures are going to be 256 meters. That is your answer. So for Pythagoras, main rule is hypotenuse squared equals to the sum of the squares of the other two lengths. The other two lengths are opposite and adjacent. Next question says that Marcus makes a steel framework. The framework is in the shape of the right-angled triangle ABC shown in the figure. The steel that Marcus uses costs $22 per meter. The steel can only be bought in a length that is a whole number of meters. Work out the total cost of the steel that Marcus buys in order to make the frame. So this question mixes up problem solving and Pythagoras. So as you can see, we have a right angle triangle and they're using steel to make a steel framework that looks like this right angle triangle. So to find the total cost of the steel, we need to know how much steel is being used. And for that, we need the length of AC over here. So as you can see, once again, we have to find the hypotenuse. So which means the formula is again going to be AC squared equals to 4.3 squared plus 6.4 squared. So that's going to give us 59.45. Then we're going to square root 59.45, and that equals to 7.71 meters. Now, if we add all of the lengths to find the total length of steel that is being used to make this framework, so perimeter is going to be 7.71 plus 4.3 and then plus 6.4. That gives us 18.41 meters. They said that he can only buy the length in whole numbers of meters. So we will round this to 19 meters. We're not going to round this to 18 meters because 18 meters would be less. We cannot make the frame out of 18 meters. We need 18.4. So to make sure the frame is being made, we round it up and get 19 meters. So since we're making only one framework, so for the cost of steel, we will times 19 with the cost per meter, which is 22, and that equals $418. So that is the total cost of the steel that Marcus buys in order to make the framework. Then the next question says the diagram shows a rectangle and a diagonal of the rectangle. Work out the length of the diagonal of the rectangle. Once again, the same type of question but worded differently. We have to find the hypotenuse again. In a rectangle, you need to remember that all angles are 90. So that means we have this right angle triangle over here, which I will highlight for you. This is your right angle triangle. So we're trying to find the diagonal, which is the hypotenuse again. So let's call this x. X squared equals to 8.5 squared plus 5.6 squared. That's going to equal 103.61. So x is going to be square root of 103.61. That's going to give us 10.18. We have to round this correct to first decimal place. So that's going to be 10.2 centimeters. That is your answer. Question 3 says in triangle PQR, S is the point on PR such that the angle RSQ is 90 degrees. RQ is 14, RS is 10, and SP is 5. We have to work out the length of PQ. So we have to find this. To find this, first we need the length of QS, because if you look at the triangle PQS, that's also a right angle triangle, because PSR is a straight line. And on this straight line, if one angle is 90, the other is also going to be 90. Why? Because the sum of angles in a straight line is 180 degrees. So keeping that in mind, we need two lengths to find the third length. So using the triangle PQ, so using the right angle triangle SQR, we first find the length of QS, and then we use that length to find the length of QP. So first, let's call this X. So now if you notice, this is different from the questions that we've done so far. In this one, we're not finding the hypotenuse first. We're finding the other length. So formula would still be the same. 14 square, which is your hypotenuse, equals to x squared plus 10 square. But now instead of adding, we will subtract 14 square and 10 square. So if we compare this with the previous questions, when you're finding the hypotenuse, you're adding the square of the other two lengths. Over here, when you're finding the other length, you're subtracting the square of the other length from the square of the hypotenuse. So for finding the hypotenuse, you're adding them. For finding the other lengths, you're subtracting them. So now we do 14 squared minus 10 squared, which is 96. Then I will square root 96 to find x. That's 9.79 centimeters. Now we use this to find QP or PQ, whatever you want to call this. And in this case, now PQ is again the hypotenuse. So you can compare the two methods now. PQ would be 5 squared, PQ squared, sorry, plus 9.79 squared. So over here we were subtracting, now we're adding. So that's going to be 120.844. Now we're going to square root this. That's 10.99 centimeters. That is your final answer. This question says that the diagram shows an isosceles triangle ABC. AB equals to BC. Since it's an isosceles, so obviously two lengths are going to be equal. The height of the triangle is 6 centimeters. We have to find the area. So to find the area, we need the base as well. Because area of a triangle has the formula of 1/2 times the base times the height. We have the height, we need to find the base in order to find the area. So to find the base, we're going to use Pythagoras because as you can see, they've highlighted the right angle in the triangle. So you can split this into two equal right angles and then use this information to find the value of x. And then we multiply the value of x by 2 to get the complete base. So 7.5 squared equals to x squared plus 6 squared. 7.5 squared minus 6 squared equals to x squared. 7.5 squared minus 36, that's 20.25. Then we're going to square root this. That's 4.5 centimeters. So base is going to be twice of 4.5, which is 9 centimeters. And area will be 1/2 times 6 times 9, which equals 27 centimeters squared. That is the area of the triangle. Then this one says that the diagram shows a shape made from a right angle triangle in a semicircle. AC is the diameter of the semicircle. BA equals to BC equals to 6 centimeters. Angle ABC is 90 degrees. Work out the area of the shape. Give your answer correct to one decimal place. So this is similar to the previous question. We're mixing up Pythagoras and finding the area of a compound shape. So to find the area of this compound shape, we can see that we have the length of AB and BC, but we don't have the radius of the semicircle. Or as you can see, the diameter. So now to find the area of the semicircle, we need the radius. So first we'll find the diameter using this right angle triangle, which is attached to the semicircle. AC acts as your hypotenuse because it's the diagonal over here. It's the length opposite to the 90 degrees. So AC squared equals to 6 squared plus 6 squared. AC squared equals to 36 plus 36, which is equal to 72. And AC is root of 72, which gives us 8.49 centimeters. Now, this is also the diameter. Diameter equals to AC, which is 8.49 centimeters, which means the radius is going to be half of 8.49, which is 4.245 centimeters. So now for the area of the entire compound shape, it'll be 1/2 times 6 times 6. That's the area of the triangle. This is your base. This is your height. Plus area of the semicircle. That's pi times 4.245 squared divided by 2. Why divided by 2? Because it's a semicircle. It's not a full circle. So let's calculate this. 18 plus 28.31. That's 46.3 centimeters square as your area of the given compound shape. Next question says the diagram shows an isosceles triangle. Work out the area of the triangle. So this is very similar to the question that we did. In that case, we didn't have the base. We had the height, but in this one, they've given us the base. We need to find the height. So steps are going to be pretty much the same. We first split the triangle into two equal right angle triangles. This 8 becomes a 4 because we're splitting it into two equal halves. So now we find the height using Pythagoras. So 8.5 squared equals to 8 squared plus 4 squared. 8.5 squared minus 4 squared equals to 8 squared. That gives us 56.25. Now we will square root that. That's 7.5 centimeters. So area is going to be 1/2 times 8, which is your base, times the height, which is 7.5. And that gives us 30 centimeters square. That's your answer. Now for this one, it says the diagram shows a shaded shape ABCD made from a semicircle ABC and a right angle triangle ACD. AC is the diameter of the semicircle ABC. We have to work out the perimeter of the shaded shape. Very similar to the previous question that we did on a compound shape. In that case, they were asking us to find the area of that shape. Now they're asking us to find the perimeter. So same as before, we need to figure out what the diameter is of AC, and then we use that to find the radius, and then we use that radius to find the arc length of ABC. So X is AC, hypotenuse is 17. 17 squared equals to 15 squared plus X squared. 17 squared minus 15 squared equals to X squared. That's 64. And we know square root of 64 is going to give us 8 centimeters. So diameter is 8. Radius is going to be half of 8, which is 4 centimeters. So for the perimeter, it's going to be 17 plus 15 plus 2 pi r over 2. So that's going to give us, that's 44.57 centimeters. Correct to 3 significant figures is going to be 44.6 centimeters. That is your final answer for the perimeter of the shaded shape. Then it says here's a right angle triangle. Calculate the value of each. Give your answer correct to 3 significant figures. So now you should find this question to be very easy because you've done most of the difficult questions already. They have given us the hypotenuse. They have given us one of the other lengths. We have to find the third one. So 52 squared hypotenuse squared equals to 30 squared plus 8 squared. So that's 52 squared minus 30 squared equals to 8 squared, 1804. Now we will square root this to find the value of h. That is 42.47. Correct to 3 significant figures, it's going to be 42.5 centimeters. That is your final answer. Question 5 says the diagram shows a shaded shape AEBCD made by removing a triangle AEB from the rectangle ABCD. So they've given us the length of AE, which is 7.2, BE, which is 5.4, BC, which is 6, and the angle AEB is 90 degrees. We have to work out the perimeter of the shaded shape. So once again, they've combined Pythagoras with finding the perimeter. So what we will do over here is that we need to figure out the length of AD and DC. If you notice, AD is going to be the same as BC because it is a rectangle, so that's going to be 6 centimeters over here. So main thing is to figure out what DC is going to be. If we reconnect A and B, it shows that it's exactly equal to DC. So if we use this removed right angle triangle, we can figure out what AB is going to be. So that's B over here with 5.4 centimeters. This is B, this is A, and this is 7.2 centimeters. So AB is what we're trying to find. So AB squared equals to 7.2 squared plus 5.4 squared. That gives us 81. And then we square root 81, which is 9 centimeters. So the perimeter is going to be 6 plus 9 plus 6 plus 5.4 and plus 7.2. So far, I think these were like the easiest 4 marks you can score. For Pythagoras, 6 plus 9 plus 6 plus 5.4 plus 7.2, which is 33.6 centimeters. This is your perimeter of the shaded shape. So I don't know if you've noticed this so far, but like you just have to be able to identify the right angle in your shape and see how you can use that to find the missing information. That leads you to the answer. This one says the diagram shows an isosceles triangle with base length 24. The perimeter of the triangle is 54. Work out the area. Interesting question. They've given us the perimeter and the base, and they want us to find the area, but there is no height. So it's an isosceles. That means this length is going to equal to this. So x plus 24 equals to 54. 2x plus 24 is 54. Bring the 24 to the other side. So 54 minus 24. That's 30. X is 15 centimeters. So now if this is 15, like we did previously, we're going to split the isosceles into a right angle triangle. This length is going to be 12, and we're going to use that to find the height because we can't find the area without the height. That's an essential part of the formula. So 15 square, which is the hypotenuse square, equals to 12 square plus 8 square. 15 squared minus 12 square equals to 8 square. That's equal to 81. And square root of 81 is 9. So area is going to be 1 over 2 times 9 times 24. And that gives us 108 centimeters square. That's your final answer. And the next question says that ABD and ABC are right angle triangles. AB is 16 centimeters, BD is 12 centimeters, and AD is 1.5 times AC. Find the length of CD and give your answer correct to 3 significant figures. So we have to find this. And AD is 1.5 times AC. So as you can see, if I highlight this right angle triangle, we can easily find AC and then use that to find AD, which will further help us to find CD. So it's all step by step. You solve one triangle, then move on to the other, and then the other. So let's begin with finding AC first. AC being the hypotenuse. So AC squared equals to 12 squared plus 16 squared. AC squared equals to 400. AC is going to be square root 400, which is going to give us 20 centimeters. So now AD is going to be 1.5 times 20, which is 30 centimeters. So I'm going to highlight the bigger right angle triangle now. And we're going to use this to find the length of BD, which will help us in finding the length of CD. So 30 squared, which is the hypotenuse again, equals to BD squared plus 16 squared. So that's 900 minus 256 equals to BD squared. That's 644. Square root 644. That's 25.38. So CD is going to be 25.38 minus 12, which equals 13.4 centimeters, correct to 3 significant figures. That is your final answer. Then this question says that the shaded shape is made using 3 identical right angle triangles and a square. Work out the perimeter of the shaded shape. They've given us the hypotenuse and then they've given us one of the complete lengths. This is 12.8, which means this is also 12.8. They're all identical, so the height has to be the same. So using this and this, we can figure out the length of the square, which is like, the base of this triangle. So 16 squared equals to 12.8 squared minus x plus x squared, sorry. So 16 squared minus 12.8 squared equals to x squared, 92.16. And then we take the square root of 92.16, which gives us 9.6 centimeters. So this is 9.6 and this is also 9.6. Now we need to find this length over here. So to find this length, we know that this is 9.6. So this part is going to be 9.6. So this over here is going to be, we call this y, and that is going to be 12.8 minus 9.6. Look at the diagram closely. The base of the triangle is the same as the length of the square. So this would also be the same. This would also be the same. So if we subtract 12.8 from 9.6, that gives us the length of this part over here, which is equal to 3.2 centimeters. So perimeter is going to be 16 plus 9.6 times 2 plus 16 again, then again plus 3.2. That gives us 70.4 centimeters. That is your final answer. Question 11 says the diagram shows the quadrilateral ABCD. In the diagram, ABC and DAC are right angle triangles. BC is 6 centimeters, AC is 7.5 centimeters. The area of the quadrilateral ABCD is 31.5 centimeters square. Work out the length of AD. So we have the area of this entire quadrilateral and we have to work out this length. So we can see that both the triangles are right angle triangles and they make up this quadrilateral. So we can write 31.5 as 1 over 2 times 6 times AB, AB being the height of this triangle, and then plus 1 over 2 times 7.5 times AD, which is the height of the other triangle. Another thing we can do first is that if we highlight this triangle ABC, we can see that we have the hypotenuse and the other length, so we can easily find AB. Once we have AB, we can substitute that in this equation, and then we only have AD as the unknown value. So let's first find AB. That's going to be 7.5 squared minus 6 squared equals to AB squared. That's 20.25 equals to AB squared. So square root of 20.25, that's 4.5 centimeters. So 31.5 equals to 1 over 2 times 6 times 4.5 plus 1 over 2 times 7.5 times 80. Now let's simplify this. 31.5 equals to 13.5 plus 3.75 times 80. 31.5 minus 13.5 first. And then we're going to divide that by 3.75 to find the value of 80. That's 4.8 centimeters. That is the length of AD. Now this one is once again very similar. You must have noticed that the questions are pretty much similar. Like they're just using triangles and like semicircles for like a triangle with a square. In this one, it says the diagram shows a shape made up of 3 semicircles now, enclosing a right angle triangle. AB, BC, and CA are each of the diameter of a semicircle. BC equals to CA. Work out the perimeter of the shape. Give your answer correct to one decimal place. So perimeter of the shape is basically these 3 arcs basically added. We can find the length of AC for the arc. We can also find the arc length of BC. It's the arc length of AB we can't find because we don't have the radius for that. For this, the radius is 3 and same over here. So using Pythagoras, we can find AB, which is the hypotenuse of this right angle triangle. So AB squared equals to 6 squared plus 6 squared, which is 72. And then we take the square root of 72, which is 8.485 centimeters. So that's the diameter. So let me label that over here. 8.485. So radius is going to be 8.485 divided by 2. That's 4.2. So perimeter is going to be 2 pi times r over 2 plus 2 pi times r over 2 plus again 2 pi times r over 2. That is going to give us 32.0 centimeters. That is your answer, correct to one decimal place. And with that, we're done with questions for Pythagoras. As you can see, I did all of the level of questions that you can get. We covered area as well. We covered perimeter. We covered shaded shapes. We covered basic right angle triangle where you have to use Pythagoras to find one of the missing lengths. Anything you can get for Pythagoras, we covered in this video. So if you're someone who understood everything, please like and subscribe and share this video with your friends. And if you have any questions or confusions regarding anything, please comment below and I'll try to help you out.